Good morning and welcome to the CADclass podcast. I'm Josh.
I'm Jake.
Y'all know the drill. We're here to show off your projects, talk about the wonderful stuff that you have made, talk some updates in Fusion 360. I said Fusion 360. Why did I say 360?
I still say Fusion 360. It's okay.
AI, by the way, every time I input anything into any AI chatbot, it just changes Fusion to Fusion 360.
Yeah, I think it's going to be a while until we all kind of go, okay, it's Autodesk Fusion, which is such... I still can't stand that they changed it. It's so silly. It's so unnecessary as well.
It really, I think it actually is hurting our sales a little bit for the book because people just don't know to search for it. Not a ton.
Yeah.
You guys are spreading the word. We're getting lots of really awesome feedback. I had some conversations with people that are enjoying this. And anyways, I want to talk about, so let's do the quick good morning. Good morning, Joestri. Good morning, Connie. Good morning, Ogre. Good morning, printed by John. It is wonderful to be here with you today. And a handful of you have been working on the challenge from last week.
Yeah.
So Jake, why don't we dive in? Can you tell us what was the challenge from last week? And
I actually don't know the challenge from last week.
You don't remember?
Was it the CAD model?
It was scaling
No, that
up.
was...
It was scaling up the
scaling
geocache project. So last week we challenged you all to scale up the geocache project with a couple of constraints. We said, scale it up, use as little material as possible, try not to use any support material.
Which is not easy.
Not easy.
The idea with limiting the support material is that obviously support material needs a base to go off of, and so as soon as you say, all right, it needs to kind of grow up and support the letters or anything like that, then this massively decreases the scale. So even though you have a 3D printer that can have like a build volume that's like 10 inches by 10 inches by whatever, it massively reduced. It may only be 7 inches in diameter because you need to add in so much support material here and there. But yeah, I love this thing. So we did see a bunch of people try this out, and I actually saw a couple of people try and print it.
Yes.
And what still makes me giggle is every single time, regardless of how many times we say it, we still see people that use a gigantic amount of infill in all their projects. I'm like, guys, you are adding
about infill. It's not about the infill. It's about the wall thickness.
I will say it until I'm blue in the face to every single person, because I feel like every single time I say it, I save a little bit of plastic in this world. But if you want a strong part, do not increase the infill percentage. That doesn't make a part any stronger. You need to increase the wall thickness. I have parts, you probably can't see it. Oh, maybe, where is it? This weird white tube, this is I think it's probably pushing 50, 60 pounds, but it's a 12-foot long piece of photography paper that I can pull down, photograph against, and put back up. And it is completely supported by some PLA brackets that I've just screwed into my walls. So it's just a little axis that just turns. Really simple stuff. But I printed it with I think 8 or 10 walls of thickness, but only like 10% infill. Like pretty standard. So anytime that I see people that have even grid that's like, oh my gosh, 25, 50%, you are wasting so much time and so much filament. It's completely not necessary, and it doesn't actually make it any stronger. Because if you think, oh, I'm dropping this on a corner or I'm hitting something, the infill is not going to be protecting that outer layer indenting. It's still going to crush through. It's just going to be crushed through less distance. So increase the wall thickness, keep the infill nice and low, save some time, save some plastic. That feels like a PSA.
And on that note, let's show off some of what you guys have made.
Let's do it.
Wait a second. Why am I not on Discord? What's going on here? I was going to announce stuff on Discord, and I am failing this morning.
How dare you? Well, can you see my screen, Josh?
I can indeed.
Lovely. All right. So first up with Connie, scaled it up 450%. As the cross section, yeah, this is perfect. This is exactly what I'm looking for. Gutting as much as possible. Like in real life, the small one, obviously you want it to screw in nice and neatly. But this one, the actual thread, this gigantically tall thread, it takes ages to actually screw it in. There's no need for the thread to be that tall. And on Connie's, it is way shorter, which is what you want. One thing that I would do in addition to this is I would actually take this bottom inner surface, this plane on the inside of the bottom screw, and I would press pull it down as far as possible till you basically only get like 6 layers in real life when it's blown up at the very, very bottom. But it just makes life so much easier. And then she also gutted around both the walls and the top section, which is actually weirdly difficult to do. I'm not quite sure why. And then I do see that she did add a fillet on there, which is fantastic. That prevents a ton of stringing, but this is brilliant. I love that. But then I think my favorite of the week, dude, Dairy making Das Boot. That's awesome. That is so rad. Josh, have you Beer Fest, the movie?
I've never seen it. No.
Oh
Why?
Why
is this? What is going on here? Why is this asking? I am just failing at all of the things. I was gonna try to. Yeah. What's that?
You can't get onto Discord?
Yeah, I was gonna announce that we're actually on this pod, but okay. Anyways, I'm on now, but I think it thinks I'm somebody new, so maybe.
Oh, weird.
I don't know. Right, well, okay. Anyways.
So be it. But yeah, Beer Fest, Turn the Boot, Avoid the Bubble. Terrible movie, but kind of hilarious. But dude, this is awesome. I actually don't know how you made it, because you can see all the ripples in the foot section, which means that this is not just like a simple shape. This is complex. But he said it as a finger surfboard challenge, so I imagine this was made with just lofting different profiles. But dude, that's really impressive. That's really, really impressive. And then for the foam, I don't know what he made the head out of. Maybe polystyrene? I have no idea. This looks absolutely amazing, dude. I'm blown away by this. That's fantastic. Yeah, 10 points. I love
10 points.
10 points.
Yeah.
I think we should give points to people. I think that's exactly how we should do it.
CADclass points.
CADclass points.
100 points.
And then Grandpa makes
100 points wins a t-shirt.
That's a good one. I like that.
You like that?
I absolutely love this. And then cutting away more material. Again, gutting the this bottom inner section of the bottom screw. It was just trying to find as many places as possible to remove material, because that will just save you so much time. And when things scale up, they just change really, really quickly. One thing that I found that was really, really strange is that when you have a normal part that you set is, let's say, 4 walls thick, 1.6 millimeters. That's nice and strong on small scale. And then as soon as you blow it up to be 500 times, you've now got wall, infill, wall. And it's actually less strong. And so you're actually better off blowing it up and then gutting more material, and that will give you a stronger print, which is very, very, very strange, but that's totally how it works. So yeah, that's going to be that's going to be it for the giant geocache. I do want to make some more gigantic projects. Anytime we have a booth, having it be just huge is just so much easier to see. So if you guys have any other recommendations of any of the projects that we make in the course that you want to see gigantified, please tell me, and I will get on printing. Gigantified.
That's a great word.
Thank you very much. I'm going to patent it.
And Derry commented on the boot, and he said, I overthought it for so long. It's just lofting, and it works so well. The head or foam was originally what you guessed it was, but I ended up using a water bubble appearance, I think it was called.
What?
Yeah. There you have it. PC Van Vliet, Mr. Mitnick on the Discord in the house says Saturn V.
I have my Saturn V rocket on the floor, and it is 1-to-1 scale.
I think
we
should make a full-size Saturn V.
I think that's a terrible idea. This is my Saturn V rocket. The one thing that I do want to make, and this is potentially it's been on my list for about a week now to make, and I haven't had the time, but this is potentially something that I ask our lovely community to do. Anytime I take this to a booth, I always lay it down on the table, and obviously that doesn't look very good. I would love to have it standing up, but it is ever so slightly, or the middle thruster is ever so slightly far out. So I can stand it up. This thing is so tippy, so incredibly tippy. And what I've seen people do in the past, where they make things like lamps, they have this gigantic, usually clear or white smoke, big bubble thing that's all organic, and it looks like the thruster's putting out all this fire. And they just put some orange or yellow LEDs in there, and it looks amazing. But it just screws into the bottom of this, and I want to make this really, really badly. So it's maybe off an angle or something like that. That would be awesome. But I don't have the time. And so if you guys want to go ahead and design something, you can take a measurement between the two centers of these. I think it's about 56 mil. But if you can make that really organic big smoke that then has some areas for some screws to pass through it and then into the base of my rocket, I will totally print it out and I will put it at every single event. And every single time someone goes, "Oh, that's amazing," I'll go, "Thank you. One of our Discord members made it and I love it."
So why don't we? I know you had ideas for other challenges, but we have the printable model. So that whole model
That
is
is
up on
true.
printables. I'm going to share it in the chat here, and I'm also going to share it on Discord. Why don't we make that this week's challenge?
That sounds kind of cool.
Yeah. So we'll clarify exactly what that means, and we'll grab the rocket parts and share them all up with you all and see what happens. Because I don't know about you, but I'm feeling really positive and excited by all the challenge stuff coming in, and it just gets me all jazzed every time. Like, this is
Yeah.
cool. This is fun. I love this.
I do love all the challenges. I find that anytime that I see people do the challenges in the book as well, I just guarantee that those people are going to go the entire program and graduate. And it just makes me so happy because I'll see them just week by week making all the challenges. I'm like, they're going to do it. They're going to go the whole way. And I'm like, come on.
I
It makes me
saw
so excited.
I saw something come in today on Twitter from Moses in our Discord. Moses, I don't remember. Like, he's pretty talented. He's
Oh, yeah.
he's a mechanical engineering student in Nigeria, I think he is. And it's,
That's pretty groovy.
you know, when we talk about this all the time, but I very much believe that in a world where there's infinite distribution, right? We can get this podcast out to everybody. We can write our books. That the best resources and teachers and people end up teaching the entire world. And, you know, I talk a lot about, like, what would it look like for us to become the world's CAD teacher, and how can we continue to build resources to support people in learning this kind of stuff. And when I see people like Moses come in from Nigeria as a mechanical engineering student, rocking through our program, sharing the finger project on Twitter, I'm just like, it's happening.
It's so awesome.
Happening.
For anyone that doesn't know, I think this is true, but I think Nigeria has the highest percentage of engineers of any African country, and it's just such a meme that if you meet any Nigerians that have like, "Oh, I'm vacationing in the US. Oh, what do you do? I'm an engineer." It's every single time apparently. Oh my, that's so great. But I've been meaning to go to Nigeria for years and years and years. Oh, I'm very jealous. Josh has been to Africa twice, and I've never been, and he's too up on me. Very annoyed. I need to catch up to him. But I've been chatting with my fiance about going to Africa and like spending a couple of months there, just going down the whole coast for years and years and years.
Oh, Africa is such an amazing place. Yeah.
I need to beat you, man.
And I mean, everybody, this is not even everybody. Basically, most of the people in our chat right now that I'm seeing are in Europe as well. So, you know, welcome Europe. I had this. We've been talking on this idea of
welcome Europe.
Welcome Europe.
Yeah. Hey guys, how's it going?
I've had this idea now. We've been talking a little bit about the CADclass Ambassadors program, where we get together with some of the top people and we chat, specifically teachers and especially people wanting to roll this out in a teaching setting. But I was just mulling it over this morning, and I'm like, I would love just one ambassador from every country in the world. Just one.
That sounds amazing.
And so maybe we'll do that at some point, and I'll find just one ambassador. We'll have somebody that just we get to chat with from each country, and then we'll make a game of it.
I would love to go there and go, oh, yeah, I'm just going to call up so-and-so. We're going to go to the pub and have a pint, or I'm going to go to this lovely tea shop, or I'm going to go to this fantastic
Dan
cafe.
says I'm in the UK, not Europe.
I'm very much a European. I feel
You're European? Yeah.
Well, here's how I know I'm a European, and it's a very loosey-goosey term. Anytime that I make a bit of toast with some jam on it and I put butter on it, my fiance, who is an American, puts on the thinnest veneer of butter and I lash it on. And
Oh,
she goes, oh, ooh."
oh.
Yeah.
Toast is a vehicle for
Lurp,
butter, not the other way
Lurpak,
around.
Kerrygold, doesn't matter. I lash it on. She goes, "You're European." I go, "Yeah, kind of." That's how it goes. All right. So, one thing that we did want to talk about really quickly is Fusion Fundamental Training. This is one of the programs that we're starting, or that has been started. No, that's a lie. I'm going to start from the beginning. Autodesk has a program where we can teach different educators something called their Fusion Fundamental Program.
Fusion
Where,
Mental Fundamental?
what did I say?
Yeah, you're as good at talking to me as I am.
This
Fusion
is
Mental
as
Fundamental.
badly as I talk in real
Fusion
life, though.
Mental Fundamental.
Fusion Fundamental Training for Educators. There we go.
Boom.
And
Mic drop.
the idea is that people like us who are approved by Autodesk, we can then teach educators who can then teach their classroom. That's the whole idea. They give us a fairly short set of curriculum that we need to teach, all the things that we need to hit. And because we don't like that and we go, well, if we're going to do it, we may as well overdo it attitude, which I apply to everything in my life.
Everything worth doing is worth overdoing.
Is worth overdoing.
That's
Beautiful.
right.
Adam Savage. Then we need to go ahead and make it cooler. So we are like miniaturizing / compressing / making it difficult in some places our entire program specifically for educators. And this is going to be rolling out, well, in the next couple months potentially.
We're gonna
as a fully formed entity.
We're gonna finish
As a
draft
finished
one.
entity.
We're gonna finish draft one probably by Friday. So we made a ton of progress. So the frame of it is this is a 12-hour Fusion Fundamental training session for educators. And we thought, just like we thought, by the way, with our first book, where we filmed a bunch of videos and they said, what if we just turn these videos into a book? How hard could it be, Jake? How hard could it be? Very hard. But we thought, well, we may as well, if we're going to teach a 12-hour Fusion Fundamentals course, you're teaching it, I'm teaching it, and then our collaborator, Ed, in the UK, is also teaching it. We thought, why don't we just put our heads together? We'll turn our 12-hour Fusion Fundamental course into a book. This is meant to live alongside of the BFB, we're calling it, the big freaking book for the young ears in the audience that don't want us to say what it actually stands for. But the idea is that it lives alongside of it, and then it goes much more over the fundamentals, and it gets you practicing and poking around and playing and thinking and wondering. And so if you don't mind, I'll just quickly show what this is going to look like. And then for anybody in our audience who's an educator or who needs to teach classes, this will be a great opportunity for you to take this and then start to be able to roll some of our curriculum out to people that you work with. So we're really trying to continue not only to support you on your learning journeys, but to imagine that the people that we're inviting in and working with and who are getting really good at this stuff, you're also going to become educators. You're also going to be running classes and teaching people. So we're hoping to support you there. So I'm going to share. I'm going to try to share my screen here. Present.
You can do it, Josh.
I can do it. I can do it. Share screen. Which one are we sharing? This is the one right here. And then I'm just going to blow this up to full size. Pardon?
Shift R to get rid of all those lines.
Present. Oh, yeah. And then I'll get rid of those lines. I think when I present, they'll go away as well. All right. Can you see that?
Yep.
So, and Jake, some of this is even new for you. You haven't even seen all of this.
I know. I've been working behind the scenes.
Yeah, this is not exactly what the cover is going to look like. I'm sure, Jake, you're like, it's going to look better. So Jake is our design wizard. But the Fusion Fundamentals workbook, and kind of why it's interesting here, it's going to be a lot of ticking boxes, checking off, checking for understanding, kind of going through some of the basics like this. And I wanted to kind of show you, it starts off with just like, what is CAD? Why are we even doing this stuff? Fill in the blanks.
Keeping it very, very simple.
Very
the idea
simple.
is that we're going to be having a student and a teacher version. So we can roll it out to as many people as possible in a very similar vein to our Tinkercad book, where it's like, yeah, we have the student version and the instructor version. They're both kind of working hand in hand for their specific audience. But one thing that we've been wanting to do for a long, long time is to have a very simple fundamental book for Fusion, basically for all CAD, all the CAD programs that we plan on teaching. And it always turned into, well, this is very boring because you can't teach really super fun, cool, big projects fundamentals in a book that thin, it just doesn't really work. And so if I want to go through and teach you all the nitty gritty stuff, it's no fun. Nobody has a good time. I don't have a good time teaching it. You don't have a good time learning it. And so it's always been, it's on the back burner. And so this way, we can get you guys learning the absolutely fundamental things in as clear and precise a way as possible. One of the things that we, as we've kind of taught more college age students, strangely enough, we find that they go through a really healthy amount of the book, and then they kind of reach out to us and they go, "Hey, I'm working on the Tesla turbine." And we're like, "Oh, great, that's like almost halfway through the book." And they go, "I still don't know how to use constraints." And we're like, "Oh no, that's not good. That's really not good. That should be really fundamentally locked down." And so then we rewrote the book for the second edition, plugged it in, and hopefully all those concerns are now gone. But if you are still needing help on the really fine nitty-gritty stuff that's kind of gets overlooked pretty quickly because the people that are teaching have too much experience sometimes, and it's hard to put our feet in the shoes of a beginner again. Hopefully this is going to be rectifying all of those problems. So yeah, take it away, Josh.
Beautiful. You said that really well. So this is likely going to launch October 15th because I'm planning on being at Autodesk University October 15th. And I want this in my hands for Autodesk University October 15th. So that's the goal. We set ourselves an insanely tight deadline for this. And I'm just poking around a little bit. You guys will recognize the donut. Obviously, we took the donut into mind here. And then we just kind of force people to slow down, notice things, tick off boxes, play, right? There's the same style stuff here. So the donut you will definitely recognize. But it quickly goes into, okay, well, now that we've revolved something, what is it? What else could we revolve, right? A little bit of playing around. And this is really how you stretch and bend and expand your mind and get better at learning CAD. And by the way, that's what we're seeing in our challenges. That's what we're seeing by all of you sharing all of your stuff on our Discord. We're seeing amazing stretching and bending and CAD growth from all of you. So we're just trying to continue to play on that. So this is just the brief little preview of what's coming. We're going to have some challenges that you recognize and then some challenges that you don't. And again, this is designed to be a workbook for educators, a workbook for educators to learn, and then also that same workbook you can roll out to students, right? So you learn from the workbook that you're then able to give out to other people, as well as why am I doing this, and the context behind the teaching as it goes. So, and Fusion they have a fundamentals training. What in the world? Jake, what the heck? So if you guys have been on Fusion's website for their fundamental training material, it leaves something to be desired. So my hope is that we can go to Autodesk University and actually convince them to roll this out broadly to all their folks. So this will look way more amazing, by the way, when Jake's design skills get a hold of it. But that's just some of what's to come. And Jostri says, this is pretty cool. Guess I'm going to need to get a copy of this book for our next event as well. That'd be amazing. Amazing, Jostri.
That sounds cool.
And that's coming up, I believe, in November. So Jostri is the Richmond Area Bot Instigated Destruction Robotics League.
Every single time every single time you get that acronym, I'm always impressed. Every single time without fail. I'm like,
I don't even know.
God, he's good.
Right. I don't even know if I got it right.
If you have never gone onto Autodesk's website and watch all their training videos, I highly recommend it because you will finally understand the phrase, "A camel is a horse designed by a committee." You'll finally understand that phrase. It is is that not absolutely accurate? It is a very, very, very strange learning course that's made by many, many people that do not talk to each other. There's no curriculum. It's very strange. But yeah, that's why Autodesk and us have a bit of a relationship going back and forth. So that's why we get to teach it. If you're interested in this course, it's a 12-hour learning course. It is just for educators, unfortunately. So if you're a teacher or you work with an institution or a college or anything like that, definitely reach out to us and we can get you touched with our course. The training course is completely free, so please do not worry about the price of that. As always, we give all of our books away for free on our website. We're going to be hosting on Amazon as well, but there is absolutely no price barrier to get through to join this course. Yeah.
Yep.
It's just for a bit of fun.
Totally. Yeah.
Yeah. All right.
Have we showed off everybody's amazing stuff? I know I was like poking around on Discord there for a second. Did we get a chance to show the challenges and projects being made
I
by?
think so. Let me double check.
Yeah. So I know you were showing some of those. Yeah, and that
so we
was,
did have a bunch of people from last week actually really killing it and going through all the stages of how they built up that project, which is just fantastic. I loved all of these things, guys. This is always a ton of fun to see. But one thing that we want to expand on this is kind of continuing on with these challenges, because they're either incredibly simple or incredibly difficult. And this was a very, very simple one, but we're going to be expanding on that and doing something a little bit more tricky today. But one thing that I wanted to go on and kind of talk about very, very quickly is that Autodesk put out a update, or a September update, that was actually chock full of lots and lots of stuff. As I was going through it, there's a load of different areas that I'm like, oh, we're going to apply it to this project and that project and that project for version 3. But if you haven't looked at the article, definitely take a scan through it. There's lots and lots of good stuff on there. I've still yet to ever go into the electronics, the PCB area, because I know nothing about PCB design. But it just seems like that gets so many updates, and it's so
they're working pretty heavily
good
on integrating that, right? And it's, again, why did you have to drop the 360 from the name? It implied the tool does everything. And okay, anyways, yeah, but I've been chatting a little bit with Ed about that too, and you can pretty quickly drag a circuit board from Tinkercad into Fusion and then automatically make it. And I haven't played around with that feature at all.
That's amazing.
But it's by this time next year, we should have made a custom circuit and talked a little bit about it.
If you guys haven't really taken a look or played around with Tinkercad, I know we haven't talked about it in a while, but we put out our book, Mastering Tinkercad, and I came into it with a very, I think, a snooty nose, stiff upper lip, going, well, it's a child's program. It's like learning coding as an adult using Scratch. It's totally not the tool for me. And then after going through the book and working through it and really kind of taking a deep dive, I was incredibly impressed at all the stuff in there that you can do that in some areas outperform Fusion and outperform other professional programs in their simplicity, in their usability, not necessarily their complexity, but absolutely in taking something that is normally painstakingly awful and making it completely simple to play around with. So if you haven't messed around with Tinkercad, definitely give it a go, because you'll be pleasantly surprised.
Let me give you one example. One example is laser cutting. You can take a 3D object in Tinkercad, move it up and down, and wherever it intersects the plane, you can turn that into a laser cut part.
Yeah.
And it's fluid, and it's obviously you're not going to get it exact, but if you've got a 3D object that you want to slice and laser cut, I mean, that's pretty tricky to do in Fusion.
Well, here's the thing. There used to be a program, and it doesn't exist anymore. In fact, if I used to have it downloaded, and then I stupidly deleted it. If anyone has it, I highly recommend you post it on somewhere that we can download it. But it was, it was called, I think it was called Slicer for Fusion 360. This has nothing to do with their 3D printing slicer that is inside Fusion. This was almost entirely for a laser cutter. So you could import a 3D model of anything, and it would slice it up. If you said, oh, I want to add dowels into it, then it would add in cutout holes for dowels. It had automatic numbering systems. It would stack up anything you want and then really efficiently lay it into a board that you specify the size. So you could do it out of plywood. One of William Osman's very early videos that went very big is that he turned a 3D model of Vin Diesel, and he used this program and made a sandwich using cheese and turkey slices. It was just said it was disgusting, but it was amazing. It is such a rad tool, and it was easy, and it was beautiful, and it was amazing and simple. No longer exists anymore, unfortunately. But cutting it up into many different layers is really, really, really difficult and time consuming to do in Fusion. And in Tinkercad, it is so easy. You go, oh, well, my material is quarter of an inch, so I just move it down quarter, and just do it over and over again, and it maybe takes a couple of minutes. And it's doing that in Fusion requires intersect projection planes, multiple STL redownloads, and it's awful, and it's such a pain. And I wish they brought that program back.
And for those
In
who
fact,
have maybe forgotten, by the way, in Fusion, any sketch, you can right-click any sketch, export it as a DXF, and
Mhm.
most laser engraving software will recognize DXF, and it doesn't.
Yeah.
If it doesn't, you can use a DXF converter. So if you wanted to laser cut something in Fusion, all you need to do is right-click, export DXF on any sketch, and you can
Mhm.
do that. And then obviously in Tinkercad, it's in the Mastering Tinkercad book as well, but laser cutting is as simple as cutting the plane and exporting it at exactly the spot that it intersects the axis.
Mhm. It's fantastic. So to continue off of that, there was a bunch of updates all throughout the program. But one area that there was a bunch of them that I didn't get to read through was in the offset tool, which is super duper simple, but I haven't played around with it at all. So I wanted to play around with it live, just so people could maybe see what is available and what isn't. Go ahead and share my screen. So I did see a couple things that seem obvious, like offsetting and offset. Why haven't we been able to do that for so long? I don't know. But we're going to be playing around with some of this stuff today. I'm just going to be making a very simple shape. Let's do a, there we go. Let's do a square with a fillet applied to one corner. There we go. And I'm going to be offsetting this face. So normally we would go into the offset menu, or you can type O for offset. It's a little bit more beefed out. Okay. So currently we have chain selection checked. You'll see this setting all over Fusion. It just means that anytime you put your cursor over one line or an arc, anything else that is connected to it, like a chain link, is also highlighted. If I uncheck this, it only applies to that one section that you checked, or that you covered over. So I'm going to select that. Normally the offset goes off. Let's set it to 10 millimeters. Groovy. Then I want to offset that again. Oh, whoops. Typed P. Offset. There we go. I cannot select offset constraints that don't match topology. ¿Por qué? What?
Look at this amazing new offset tool live.
A bunch of liars.
Yeah.
What? Whoa. We were. More information. Cannot select offset constrained curves that don't match the topology of the parent curves. Turn on match topology. Okay. I'm gonna check match topology. Click it. You get the same error.
Okay, what's it say?
Whoa. Cannot select offset constrained curves that don't match the topology of the parent curve. Select the original curve instead, or remove the offset constraint. What? Do you understand this?
I think it's glitching out with the constraints. I don't know which one. Try something unconstrained. Exactly. Yeah. So try an unconstrained offset, and then try to offset that. No, it still doesn't like it. Oh, okay. Well, can we not offset it?
Okay. Wait. Let me. This is now very strange. I'm glad we're working on this live so everyone can see that maybe it doesn't work as well as we purported. Let's add an offset. Groovy. Let's do another one. Yeah, cannot select offset curves. Turn on match topology. Yes, sir. I will turn it on. It's the original curve. What? That's bizarre. Okay, I will do a little bit more research into that because that's very silly.
Let me poke around. Yeah, so let me see what the actual update said. Offset update Autodesk Fusion. I'm just gonna look into this while you're trying to jam with it there for a second.
I'm gonna try the other two-sided one because this one was actually really lovely. So I can check two-sided, which essentially adds an offset to the outside, and the inside, which is really good actually. I've been wanting this so long. But we also have a new thing called link offsets. And I think this only applies for two offsets. What's the best way to put this? That essentially intersect with each other, which is why I kind of made this funky shape. So I'm going to be mirroring this whole profile about that vertical line. There we go. So now we'll essentially have two offsets that merge into each other in weird ways. So let's go ahead and let's do an offset again. I'm going to select both.
Do you have the most up-to-date version of Fusion?
Yes, sir.
Okay. I'm going to try to offset and offset right now, too. Keep going.
All right, I'm going to uncheck chain selection. Just going to move my way all the way around. So it's adding it to the inside, or to the outside, which is fine. That all looks good. If I check two-sided, it's going to be doing a little radius on the inside. Lovely. So that all tracks just fine. Then if I check link offsets, does anything change? Not really. Let's explore a little bit deeper. I'm making a similar thing again, but having a gap between it. Oops. Not filled. Give me back. There we go.
Oh, here we go. It works for me. Works for me. Weird. Okay. I was able to offset an offset of a rectangle.
What shape did you make?
Rectangle. Just on the origin.
What?
Worked for me. So O for offset, click the shape, drag it out.
One sec. Let me just try and do this really quick. So I'm going to select these two profiles. Oh, but now it's not letting me. Oh, that's because I'm actually a little dumb. That's usually the fix. That's usually the fix to most things in Fusion. It's just me recognizing, I'm actually just kind of dumb sometimes.
So PC Van Vliet says Fusion does this just to mess with Jake during the pod. I agree with you.
Basically, yeah.
I agree.
But that's kind of part of the fun of me just.
Yeah. And then Connie, Connie also says, I already tried it some days ago and it worked, and now I have the same problem. So, a little bit buggy, maybe.
Interesting.
So sorry, keep going here.
Just move my way all the way around. Fascinating that it wouldn't work like that. That it wouldn't work completely perfectly. Interesting. Okay. So I've got this two-sided tool. Yep, goes up just as normal. But I still don't know what link offsets mean.
What is this? Link offset, you said? Oh, I don't have that option. What's going on?
It's only when you check two-sided. I am not sure what that means. Those look totally identical.
Link offsets. Links the offset parameter dimensions of the two sides. So when you change one, the other updates to match.
Wait, so
links.
Say that again?
Links. It says it links the offset parameter dimensions of the two sides. Yep. So when you change one, the other updates to match.
But it's symmetric. It's the same thing.
This is symmetric. I don't know. Yeah.
Wait. So I'm gonna not have. Okay. Wait. So if I increase that to something like -8. Okay. So So then if I two-sided, if I link them together. Oh, FX. Okay. Yep. Yep. I'm totally with you. Okay. So that totally does work. Let me try this offset again.
Yeah. So I just drew a rectangle at the origin. Just draw a rectangle and then offset it.
Yep.
And then offset the whole thing.
Whoops. Change selection. There we go.
And then click the click match topology. Click
match topology.
Yep. Okay. And okay. And now offset. Now see if you can offset that.
Wait. Match topology.
There you go.
Hey, okay. So I didn't click match topology on the first offset.
You have to click it on the first offset. Exactly.
Okay. So let me just do that again with our first example, just so I'm not crazy. Add filter to that corner. Fantastic. Looks the same. Okay. So I'm going to be offsetting with the chain selection turned on and match topology turned on. Groovy. Got an offset. Going to do the same thing. Match topology is turned on. Hey. Okay. That's perfect. What the hell does match topology
I'm reading it right now.
mean?
It says limits the offset distance range. Weird. And maintains the topology of the offset so it matches the selected curve.
Okay,
Why wouldn't it match the selected curve?
Because if you imagine if you have kind of like an infinity shape and you offset that from the outside, it just kind of gets this
I see.
wavy racetrack shape. But if you offset it internally, then those dissociate into two kind of teardrop shapes. So they do become disconnected from the profile, which I get. Okay, that is really handy. Well, the first place we're going to put it
Is the
uh, is
guitar.
is on the electric guitar project.
Yes. Yes, yes,
The
yes,
fact
yes.
it is always annoying knowing the limitations of the software, teaching it, and unfortunately having to go to tell people, yeah, this is just how it goes. I'm sorry. That stinks. And they finally fixed something that's really, really elemental, and that makes me so much happier than making a new tool. This is always much better.
I
Oh,
agree with you. I will say there is a trade-off, and that trade-off is the more you get to know a software package, the more you get to understand its strengths and weaknesses and its bugs in some cases. The
yeah,
more
yeah,
consistent that is over time, the easier it is to teach it. Part of the difficulty of teaching these programs is that when
true.
they change, they sometimes break other functionality or they sometimes break workflows. And so I think if you had to ask yourself, why is the Autodesk Fusion documentation subpar in a lot of instances? I think the answer would be exactly because they are updating the software so often. They're
Mhm.
trying their best to make it better and better. And so there's this trade off between teaching something that isn't perfect, but understanding and thoroughly, you know, I guess understanding
Mhm.
is the word I'm looking for. Understanding the bugs and the nuances of it. That's probably the issue. Some of
Yeah,
this.
no,
So
I totally agree with you. Yeah.
yeah.
Okay. Uh, Josh, if you want to keep on talking just for a minute, I'm going to be posting the new challenge onto our Discord.
Are you so we originally talked maybe we would challenge people to make the rocket part. Do we want to hold that off for now and we want to work on this challenge? Or do we want to
Mm,
use this
Well,
challenge?
I'm gonna be making that project now, anyways.
Okay.
So I'm gonna post it. Well,
This
give
one that
both.
you're working on right now. Okay.
Yeah, if you guys want to go above and beyond and do this challenge that I'm going to be making, as well as help me out, that would be incredibly nice. But obviously, you don't have to. But if you just want to talk just for a minute, I'm just going to go ahead and post it on our Discord.
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 No, I don't really want to talk for a minute. I don't like talking. We have a
Oh my
podcast, so
god,
why would you do such a thing?
that is so annoying of you. I can't believe you.
um yeah, it's funny. You
I
just oh, I think I
can't
just
believe you
listed
went.
it.
Yeah, so I just posted the link on there. I'm just going to be posting a picture of the drawing as well. It's a little bit low quality, but that's how she goes sometimes. So let me just go ahead and add this onto our Discord and get that processing. Okay. So
What is
uh,
this thing?
I know. So so the problem with all of these 3D modeling projects is that they're always really weird, funky nonsense things. They usually always flanges, which okay, all right, fine, fair enough. But they're always really strange. So as always, if you guys didn't make the last one, uh, usually going to be coming with an isometric view, three-dimensional view. It's also going to be having a front, top, and right view. It's always going to be a little bit tricky to actually see what's going on. Um, but that is the challenge: is to recreate it in as few steps as possible to be as efficient as possible. I literally just picked it out this morning, and I have not inspected it at all. So I'm likely going to be making it fairly efficient, but not 100% efficient. So that's the goal: is to beat me, which is probably going to be easy. Um,
um, Jake, I want to just mention something. We have a couple
okay.
of I made a things that we didn't get to show off yet.
Oh,
3 in
excuse me.
particular, and printed by John is on here now. Connie has made something on here too, and PC Van Vliet as well. And they're all on the pod. And I want to show off
Okay.
their super radness.
On that I made a thing.
Yes, please.
Oh my
Look.
god, that's right. I didn't. Yes, 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 yes,
Yes.
yes.
Yes, yes,
Okay.
yes, 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 yes. We
Okay.
almost missed the best part. We were so sorry. Look at this.
God, that is so neat and
This
tidy.
is super, super
Lovely.
rad.
I love this stuff. By the way, really, actually, really, really good design or printing orientation by printed by John. If you want to show off a a part of your 3D print that tricks people into thinking that it hasn't been 3D printed, have the build plate surface be the showcase side. If you can kind of see from the lighting, it's got a rough texture on it, which looks exactly like a rough texture plastic injection molded part. It looks legitimate. And he is then using the actual texture of the build plate to make it look that much more professional. If I was going to print this, I would probably print it on its side so that our layers are cutting through that L shape and it makes it that little bit more stronger. But this project looks cleaner and it looks better. So hats off to you. Really good design. If you did it purposefully or you didn't, this looks brilliant. I like it. Connie finally printing the lightsaber. Dude, that is awesome.
That's
I
amazing.
love this so much.
It looks so good.
It looks so fantastic. I want to go back and remake my original lightsaber, but God, this looks awesome. And then the pictures as well.
Oh, and because
Crisp.
like all the custom lights that she's been doing in the
Yeah.
backdrop, like
So good.
as usual, we're fans. We're
Yeah.
fans.
Oh, we've always been fans of Connie's project.
We have.
Dude, this is awesome. Hats off to you. This looks fantastic. Really fantastic.
And then up a little, check out this Hue Forge print from Mr. Mitnick.
So neat and tidy. So he said that for all the Hue Forge people, switching to a 0.2 nozzle really helps. I bet. But he also said that this took 6 hours to print, which is still a long time, but it's a nice size piece, and this looks really good. Yeah, I'm just still blown away at this. I wonder how many colors this would have. 4 potentially. That maroon, that blue, that white, and that black. I think.
Yeah. How many?
It looks
You see
brilliant.
Van Vliet, Mr. Mitnick, how many? Tell us how many
This looks
colors you did. I took one of those Hue Forge prints that I made of a lion to the 3D printing training session I ran at the college. Or sorry,
awesome.
the CAD training session I ran at the college, and people were blown away.
Because it's awesome.
They were asking me for, hey, can I get a photo of that? After the fact, they were asking me for photos of that print. It is
awesome.
so ridiculous. Yeah. And then we talked about that other project.
We talked about Connie last week.
Yeah.
We've given her enough praise. That's fine.
Happy to give
but I wanted to go off and talk about this project here. This just kind of looks like a really weird flange thing. Who knows what it would be. They're usually nonsense parts. But just kind of looking at it very, very quickly, it looks like it's got this very strange rectangular flared triangle wavy base with a vertical tube, a horizontal tube. This angled section, this is called a rib. There's a couple different ways to make that. And then this extra mounded area. So as always, the first thing that I want to do is kind of get rid of all of the features that I know that I could make in a couple of operations. So this horizontal tube that's coming out, this is obviously made and projected onto this ribbed surface. That's why you can see that it's actually interfering along that vertical tube. And then the rib in the bottom left-hand corner, that I can make very, very simply with just a sketch and then an extrusion. But there's also a tool called Rib that's mainly used in the plastic injection mold facilities. So if you've never touched it, don't blame yourself. I very, very, very rarely use it.
Well, I don't think we talked about Rib in the book at all.
Oh, we don't, because we don't plastic injection mold anything. But as far as the profile goes, this kind of, it's almost like a sideways heart shape. That seems to be the most complicated, and so it's kind of making me think that that's wanting to be boosted upwards first. This little mound on the left-hand side, I can imagine that being an extrusion rectangular, and then a cut from the top, or maybe a fillet, and then a hole. But I'm likely going to be making that as a separate operation, just so I can still make it symmetric. Where else? I'm also seeing that these 2 circles that are not very tall on either side are vertically constrained to that large circle at the very center. One thing that you may not have noticed, if you take a look at this isometric view, there's actually a bit of a corner where that rib touches the circle. So this isn't symmetric. That top horizontal line is coinciding to the origin, and it's actually extruded away from it, so it is obleted to one side, which is a word I don't get to use very often. Okay, so I think we're going to be starting off making this kind of heart-shaped base with the 2 raised circles within that sketch as well. So let's try that out. What time is it now? Okay, so I've got 10 minutes to make this. Woo! Okay, that's the whole time limit. That's how it is in real life. So I'm gonna let's make a new sketch on the top plane. This is going to be symmetric. So let's try. Okay, so I'm going to be making a large circle at the very, very center. Then we're going to be making 2 more concentric circles, but a little bit smaller above and below it. These are just placeholders right now. Let's add on some equal constraints. There we go. Going to be shrinking that down. Let's add on those dimensions right now. That's going to be 9 and 18. Okay. Gosh, I really want to host one of those speed challenges for CAD.
Yeah.
That's one of the things that we should do. That sounds like a ton of fun.
We can host one
It's
of
going
those.
to be 18 and 35 for the large. Okay. 18 and 35. Okay. So then these, I don't know the distance between the centers, do we? Oh, 130. Okay. So then let's split that. So you can go 130 between that. And then I'm going to say the distance between these 2 points is going to be that number divided by 2. There we go. So now that's nice and equal. Then that's going to be an offset curve around there going into it, back down. Okay, so that's going to be a series of arcs. Okay. So I'm going to be going into the create menu and making a center point arc. So there's going to be an angled line from there that goes around. Similar thing on this point. Center point arc, and then mirrored on that side as well. Okay. So then I want to say that the outer top is 24. Groovy. How am I doing for time, Josh?
Good. You about 8 minutes left.
Oh, excuse me. This needs to be much larger. That needs to be a radius. So that should be 18, and that should be 36 actually. There we go. Now it's looking a little bit better. So then are these radii on the inside? Bugger, they are. Okay, so that actually needs to be 70 mil in radius. That needs to be 36 as well. So then I can click and drag this out. That's why it was looking kind of weird. Okay, so then those are going to go angle, vertical to that. So I've got 2 completely vertical lines that are tangent from those external arcs, but aren't necessarily tangent to this piece right here. So I'm going to make them both vertical and then collinear as well. Usually adding constraints is much faster than adding all of our dimensions. Radius 45. Oh my gosh, this is getting messy already. This is why we say to click and drag the dimensions away from your sketch, because it makes it so much easier to see what the hell is going on. Okay. And then, again, 2 tangent lines coming off on either end. I probably should have made that with a line tool, so they were already perfectly tangent. How much time do I have, Josh?
You have 7 minutes.
Okay. What is that? 56. That's 75. Okay. So I'm going to join these 2, make that totally horizontal. I'm going to be making a midpoint to the origin. That's going to be a construction line that is also horizontal, which is going to be pulling it up as well. Pull that away. Did I say 75? 75 for that. Let me check. Lovely. So the distance between... Oh, for God's sake. I'm just going to be adding on a construction rectangle from that point just to match that dome. Oh my gosh. I may make it on time. I may do it. That's 56.
You got this.
Yeah, this is exactly what I like to do right in the morning. And then 128 to there. So even though I'm not sketching this sketch is fully defined. Okay. So then that's going to be extruded up at 19 inches from there. What? So what's the thickness of this part? What? Does it not say? Oh, no, wait. Oh my god. Okay. What? What is the thickness of this foot? It doesn't say. But it has to say. Okay. Well, let's say we can extrude that section to the whole height. So I'm going to make that 119 tall. So I can at least start on that. So this circular section, 119 millimeters tall. I'm going to go back and turn the sketch back on. Those little tiny indents, those are going to be 19 mil tall. Brilliant. Okay. God, what is the thickness of this foot? That's really strange. That's not referring to anything. Let me work on that top circle really quick. So that's 89 millimeters there. How much is it coming out though? What? I can do front plane. Oh wait, is there a dimension that's been cut off? There's a line there. I should know the distance of how far it's pushed out. So I know the diameters. I know the location of that. It's going to be vertically aligned. That's fine.
Does look
But I
like that
don't know.
dimension got cut off.
It does look like it, doesn't it?
Oh, there you go.
Okay, so it's 193 from that back edge. Oh, for God's sake. Okay, so what is that? 100. Oh my God.
I love the grumps and grimes.
So it's 190. So I'm going to be making an offset plane from the origin to the front. That is 193 minus 128. Oh my, what a bunch of bastards. Okay. 193 minus 128. Okay. So I can make 2 concentric circles. Just going to make it over here. They're obviously too large. Make the top to there. Wonderful. And then how big does these need to be? 24 in radius and then 12 and a half. 12 and a half, that's easy. That's 25. And then 24, so that's going to be 48. Brilliant. And then how high is it up? 89. How much time do I have?
3 minutes.
Oh my God, not a chance. Okay, so I'm going to be extruding this to the distance to the object. So it's going to be going to there. Fantastic. I have no idea if it cuts all the way through. 48. Okay, yeah, why is it saying 48? You already told me the diameter. Useless. Okay. So that's fine, that's fine, that's fine. Wow, it does it not tell me the thickness of the foot? Am I being stupid? It really doesn't say. Okay, I haven't watched this video. I'm literally working through it live. What? Why? Well, it should give me that information.
Well, you have the height from the base, and then you have...
No, I don't. Yeah, I have the height
19?
of those 2 little pieces. Yeah. And it's obviously less. So I'm just gonna extrude that up as a value that I don't know yet. But I'm just gonna be putting it under. I think 15 is about right.
Oh,
so you gotta work on it, man.
Not the one. This is the one.
All right, so then I'm gonna go ahead and make that rectangular arc from that section. I'm just going to be projecting that construction. So I have 1 less dimension to make. There we go, there we go. Then it's going to be a central circle on there. How tall is it? What? 75 tall. But then that just says it's tangent to that point. So that's about a 45-degree angle. That's going to be tangent to there off the top point. But I can't know what that is. 75, that's fine for an extrusion. 56, that's fine as well. This is not a very good drawing, I think. Or maybe I'm just dumb, which is also completely a totally acceptable value. Is I'm just actually dumb. 3-point arc. Come on, work with me. There we go, there we go, there we go. This is why you like this segment, Josh, because I just get to have a coronary.
I love the groans. Ooh. I mean, that's how it actually goes. I talk to myself constantly when I do stuff like this. So
yeah,
it's just funny to hear it live. Yeah. So T minus 1 minute, by the way.
Oh my God. If anyone else can do, okay. So that's radius 28. I'm betting that that's going to be coincident to there. Jump up that to that. Cool. I still do not know the height of this piece. Still don't know because it's defined by that angle, which they haven't provided. So let's make, I'm just going to roughly set that to 45 degrees. If anyone can figure this out, no, that totally doesn't look right at all.
Yeah, probably more like
maybe
60.
30?
Or 30. Yeah, actually 30. No, 60.
No, sorry, 60, excuse me. There we go. That looks about right, which is probably what they want because they're evil. So then I can go ahead and extrude
10,
this symmetrically.
9, 8, 7, 6, 5,
5
4, 3, 2,
no.
1.
Oh. Well, I'll tell you what. to say that. Damn.
Close. To be continued. So we shared that with you all for anybody who wants to try that out for this week.
Give it a go.
And if you want to time yourself, that's one way to go about it, right? So we'll take
Yeah.
2 submissions. One is time from first view to completion. And the
Yep.
other submission we'll take is number of features. So you were trying to reduce either the number of features or time.
Or the time.
Your choice. Your choice.
All right, guys, that's going to be it for us this week.
That's going to be the pod. This
I'm
has
exhausted.
been the CADclass podcast. Once again, I'm Josh.
I'm Jake.
And it's
I'm tired.
Wonderful seeing you as always, as all the things as always. You like that? I don't know what happened there. But we'll see you all next week.
See you next week, guys. See ya.
Cheers.
Adios.